school topper, science topper, and subject topper of English, physics, and mathematics, scoring a centum in English and physics. He was also the member of the Qatar Debate Champion Team 2012 and one of the best speakers of Qatar. After completing his graduation and master's from the University of California, Berkeley, currently he's pursuing his PhD at Yale University in mechanical engineering, mainly focused in robotics. His experience at a surgical robotics company last year has helped him gain great knowledge in this field, and today is here to share with us on the same, robotics in real life. First, I would like to invite our beloved principal, Ms. Asna Nafis, to share a word of wisdom. Over to you, ma'am.
Good evening, everyone who's viewing this event, and a warm welcome to Vatsal from all over from the US. It's a very beautiful thought that just crossed our minds that we should involve our alumni during this very critical and crucial phase when the world is undergoing very challenging times. And one of the thoughts that crossed our mind was that we could involve our alumni from any part of the world to connect with the students of the current 9, 10, 11, and 12, especially to motivate them to, achieve greater heights. And keeping in mind that Vatsal is one of our star students, when I say star, it's not about academics that I'm talking. Of course, he excelled in academics, but he was an excellent human being when he was in school. His temperament is one of those that everybody can emulate. Very kind personality type, which is willing to ever help anybody. And I think when we threw up this idea, he was one of the first ones to respond positively. And these are some of the things that we probably teach our children, that character is more important than what you do with your academics. Academics surely is important. And Vatsal is one of those wonderful human beings who has left the portals of DPS, has stayed connected with DPS-Modern Indian School. And today's series of webinars with our alumni starts with Vatsal. Welcome to you, Vatsal. And may we have a great session with our children. Thank you.
Thank you, ma'am, for your kind words. Now, I would like to request our Vice Principal, Ms. Soma Bhattacharjee, to share a few words. Over to you, ma'am.
Good evening. It's so nice to see Vatsal on the school platform again. And every time we have called him, we have tried to connect to him. He has been always there for the school. And as ma'am said, he was a well-disciplined boy, very kind-hearted, took part in all activities. And I still remember before the boards of 12th, I think 1 week before, if I can recall, he was in Germany. He went for some debate, and I was very hesitant to permit. And I went back to ma'am to ask permission whether he should go or not, but he was very confident. And after all that, with all the pressure of activities, he performed well, he came back and he gave us the wonderful results, and he became the first Gulf topper for class 12. So it's really nice to see him amongst us, and he has always taken the initiative to connect with us, to connect with school, and share his knowledge, motivate children. He has done one more, career guidance workshop with us. So I wish him all the best, Vatsal, in future. Reach your heights that you have dreamt and make us proud, always. Thank you.
Yeah, just before we start the event, I would like to congratulate both the vice principals for the excellent results that we have achieved, and congratulations to all the students. We are toppers in both grade 10 and 12 in the entire Qatar, as well as I think we would be toppers even in the Gulf in 1 or 2 areas. So congratulations to Team DPS and all the team of teachers who have worked so hard.
Thank you, ma'am.
Thank you, ma'am. Before we start, allow me to walk you through the guidelines for today's program. Kindly keep your cameras on. Kindly keep your microphones muted unless you're asking a question. You may converse with one another via another device or another online platform. Everyone please keep your screen on speaker mode or pin Mr. Patel. You can ask questions only via chat. Once the session is over, all teachers are requested to take part in the poll and fill the feedback form. We hope that this session would enhance everyone's interest in the field of robotics. With this, I would like to give the screen to Mr. Vatsal Patel.
Thanks, Manaz. First of all, I just want to say I hope everyone's staying healthy and staying safe and taking care. It's really nice to see everyone again. And thank you for all the kind words and inviting me back to speak here. I'm really, really happy to be part of all these alumni interactions, and now and even in the future. I definitely think it's a great idea, so I hope it continues in the years to come. Like Asnam said, congratulations to all of you for doing such an amazing job, even in these really uncertain times in your board exams. So I'm really glad to see DPS again, as always, on the top. So today I wanted to give you a glimpse into the world of robotics. So I just wanted to check again if I can share my screen. I could do it in the breakout room, but I think it's disabled in the main session. Yeah, ma'am, if you could enable screen sharing or make me a co-host. So while that goes on, I'll still continue just to tell you about why or what I'm trying to talk about here. So I just want to give you a glimpse into—
you can share your screen.
Okay, yeah. So I wanted to give you an idea of what the world of robotics is like. There's a lot of excitement, there's a lot of hype around this field. You always see it in the news, but there's also a lot of expectations and sometimes an overpromise on what robots can do in our world. And sometimes there's also fear in terms of what these robots will do. And a lot of it is fiction, some of it is reality, but I wanted to sort of separate that and give you an idea of where things are today and where they will be going in the future. So I think you kind of already heard about my background, but just to give you a better idea of what I was doing at these places. So at Berkeley, I was involved in undergraduate research in a robotics lab, which worked in surgical robotics and automation and a lot of different fields. It was a very large lab. So I kind of got interested in this field in my bachelor's and my master's. And then I went on for a year to work in the surgical robotics company called Intuitive Surgical, which is also in California. And I'll show you what kind of robots I built over there and designed over there too. But eventually I thought I still wanted to learn more about this field, and I want to learn what kinds of things people are doing out there in this area. So I sort of quit my job and went back to do a PhD at Yale University. And the way PhDs usually work is you join a lab and you try to come up with a research question. That's usually the hardest part of it, coming up with a question that you want to answer. And right now I'm trying to do that also in a robotics lab here. So that's kind of a little bit about my background. And what I want to try to convey today, the goal of this presentation, is that robotics is an extremely diverse and multidisciplinary field. Diverse because there's a lot of different disciplines that come together in this field to make a product or to make a robot. It's not just your conventional mechanical, electrical engineers who go into this, and I'll give you a whole list of different fields that you might not have even imagined actually contribute to robotics. So it's extremely diverse, extremely multidisciplinary, and it's only expanding. So we're still trying to learn what the capabilities of robots are and what robots can do, and it's only going to expand in the years to come. And it's also a very young field. Only in the past decade or so have we really started to achieve really interesting things with robots. And if you think about any other profession, any other field, that is very young. So say if you think about automobile engineering or medicine, these fields have been around for almost half a century or over a century. But robotics is a very young field, and in that respect, it's also very active. There's a lot of money and interest from governments, from companies, from universities, and we aren't even scratching the surface here of what this field of what robots can do. So in general, this is the idea that I want to try to convey to you. And I'm not trying to pursue all of you to become roboticists, actually quite the opposite. I think the idea here is that no matter what field you'll be in, I think in the next decade or 2 decades, you will be interacting with robots because they'll be so widespread. Imagine computers just 10, 20 years back. So robots will be the computers of 20 years from now, is what I think. So that's why I think everyone should be interested in this field. So when you imagine robotics, when you ask someone about robotics, this is kind of the idea that you usually get. You see factory robots, so that's the picture on the left here with these giant yellow robots. For scale, you can see this is the human here. So these are pretty massive robots, and they're generally separated from the humans entirely so that you don't get hurt. But they're kind of doing the same repeated motion over and over again. So the same car is coming through, and the robot is putting parts in or painting it or doing the same job over and over again. You see robots in packaging. So this is an example of a robot in packaging and the middle top, and it's just sort of putting products in boxes. Again, the same types of products in boxes, the same sort of rectangular boxes, and doing that job over and over again. You see it in food industry. So the bottom center picture is actually a picture of from a food industry robot. So again, what I'm trying to say is automation is just doing the same kind of job over and over again. Or you see it in sorting. So these are all kind of pick and place robots, picking an object and placing it in a different container. So this all falls under the kind of the overarching factory automation. And this is what people think robotics starts and ends at. But that's quite not true. Today, robots are doing jobs in agriculture. So they're helping farmers spray pesticides, spray different kinds of compounds, or help with irrigation. So precision agriculture is a huge part in robotics where they're monitoring plant growth. So you have a giant field and you want to try to understand what part of the fields are doing better than the others. You can have a human walk around, but that starts to get tiring and also very expensive if you need to have so many humans go out in the field and then monitor those plants. So you can imagine having a robot going around and doing that kind of job for you. Medical robots are very prominent as well. You see robots as exoskeletons. So these are sort of robots that kind of go outside your body for people who might have lost function in their limbs. So these can be exoskeletons for the lower body. So you see that in this picture, the gentleman has unfortunately lost function in his legs due to some spinal cord injury, and he has this robot sort of help him walk again. You also have robots that are used in prosthetics. So these are upper limb usually. If you have lost your limb in some accident, then robots can help you sort of regain function in that limb by attaching a prosthetic arm. But you also see robots in surgical spaces, and I'll go into a deep dive on that a little bit later on. There's also a huge field, and I think a lot of you already have seen these kind of UAVs or unmanned aerial vehicles outside. You can go out and buy a drone today pretty easily and relatively cheaply too. But UAVs have been around in the military application for a long period of time as well. For sort of reconnaissance mission, or you're trying to take pictures of an enemy base or in areas where you don't want humans to go, or you want to be extremely stealth about it. So we're seeing it in professional and consumer markets too, but it has been around in military applications and security applications for quite some time. You also see a lot of mobile robots. So these are your interplanetary rovers. So Curiosity, in this case, the Mars rover, which, well, went to Mars. These are also your giant robots. They look pretty small in these pictures, but if you've ever seen a Curiosity rover next to a human, they're actually pretty big. You've also probably seen warehouse robots. So these are robots that kind of pick up shelves and then bring them to a human picker instead of the human going in a warehouse and then picking the object for you. So if you order something from Amazon or Flipkart or something, there are generally these robots which will actually go and bring the object to the human, who will then put it in a box, rather than the human walking, which is a lot slower. So these are these tiny robots which kind of go on the floor, and there's probably 50s or hundreds of them in a particular large warehouse. So these are your mobile robots, right? So there's already quite a bit of range here in these robots. But another really interesting application of robots that we're starting to see is in the space of social robots. So what are these social robots? They're robots that are generally used for elderly care, for instance, in an elderly home, or for patient care. So if you need a social companion for therapy or any other kind of reason, we we obviously do see humans as a big part of that process of giving social interaction, being a social companion to other humans who might need it. But it is, again, a field that has fewer workers than there's demand for. So robots can sort of step in and help humans through that process. The second picture you actually see is a robot being used in an education field. So this is still pretty rare. You don't generally see robots that common in schools across the world, but they're starting to come in because they're cheap. They're very easy to interact with, and they're pretty user friendly. So having a robot in a classroom can open new kinds of avenues for learning when you have a physical piece of hardware with you. But again, this is even a younger field within robotics. But there's a lot more. So a lot of you have probably seen robot vacuums, Roombas, as they're usually called. But there's iRobot, which makes Roomba. There's tons of other companies which make these robot vacuums that go around your house and just pick up stuff. The second picture is of a disaster response robot. So imagine an earthquake situation where it's hard for a human to go in, or you don't know. It's not safe to send a human in. Generally, you would send a robot in to kind of take pictures, surveil, or find other humans that might be stuck in the debris. So Fukushima disaster, which was about 10 years ago or more, they still have robots going in and trying to identify if it's safe, if trying to find the melted core and things like that. So disaster response is, again, a very big area of robots that is seen applications in. The third picture is actually of a humanoid robot. So these are robots that look like humans. You might want human-like robots if you're, say, greeting other people at a major event. Say Qatar is hosting the World Cup, and you want a robot to just show off the country's technical capabilities. So you install a human-like robot at the airport to greet incoming people. Or it might be more helpful, again, in social applications where you want a human-like robot to talk to and work with. So you aren't feeling like you're talking to a machine. So humanoids are, again, a big application. Self-driving cars are always in the news these days. Companies like Google and lots of other companies like General Motors, they all have divisions within their car companies looking at the prospect of self-driving cars. And that's again, a robot, because you have a machine trying to do things on their own without the human interference. You often have seen bomb diffuser robots. Again, these are used very commonly with police forces, with military forces, to go into situations where, again, it's not safe for humans to go in. Telepresence robots. So these are robots which kind of take you in a venue which you cannot be physically present. Again, this is very common these days. If you've seen videos of a university in Japan which was doing their graduations actually purely with telepresence robots, they didn't have to have students back at the university just for graduation. So these are just robots kind of on wheels. They have a screen and they have a camera, so that I can be sitting at home and then be at a different place. Underwater robots are very, very common. Well, they're starting to become common because there's so much of the ocean that we haven't explored, and robots are a big part of getting us to that to those depths that humans cannot go to. And again, I'm basically naming out different kinds of applications of robots, but there's so many more. If you've ever been to a Disney World or any kind of amusement park, you've seen kind of animatronic figures. These are, again, robots. Disney has a huge division within their Imagineering group, is what they call it, like Imagine and Engineers, Imagineers. And this is a picture of their, I think their Disney World in Florida, where they created a robot which looked like the Avatar from the Avatar movie in the world of Pandora, which was what the world in Avatar was called. So again, there's huge widespread of applications of these robots. And this is a graph that I thought was very interesting to see kind of where these robots are going. So back in the 50s and in the 60s, you had what I refer to as factory automation or industrial robots. And these are robots that are doing the same type of job over and over again. They might be complicated jobs, like screwing in really tiny bolts or making really precise patterns with paint on cars. But they're still the same type of job that you're trying to do over and over again. And you want these robots because they have a higher efficiency than humans. So you can have a higher productivity from your factory than if you had just humans. So that was kind of the early stages of robots in the 50s and 60s. Then people started to add sensors on these robots so that we could have more information about the world or the environment that these robots were in. But that just added more data to process for these robots. So we kind of stagnated in innovation or development of these robots. And then from the 2000s, we suddenly saw the opportunity to bring these robots in professional environments and consumer environments. So you and me could go out there today and buy a robot, right? And that's when kind of we had this exponential growth in the types and applications of robots, and that kind of you see this whole widespread area that now robots are pretty commonplace in. So this kind of gives you an idea of what robots can do. So you might be thinking, all right, robots can do everything. They're a solution to every single problem in the world, and we should just invest all our time and money into building robots for any problem that we have in this time. So you might say like they can do everything, but there's probably a majority of things that robots cannot do, and that's, I think, the more interesting part of robots, because that's where you think, all right, that's something that I could in the future go out and help in or work in. So one of the big areas of robots that is still a lot of room for improvement in is visual perception. So you and I as humans have great eyes, and we have skin, which is a great organ, because we can feel, we can sense pressure, we can sense temperature, we can see depth. So our two eyes actually give us a depth perception. So we take two different images from our left eye and right eye, and that gives us an idea of how deep things are. So even if things are in the same line, you can still tell that one thing is further away from you than the other. That's actually a lot of information for a camera to process. So your phone camera, for instance, cannot just tell you depth, cannot give you depth perception unless you have more than one camera on your phone, right? So that's just one aspect of your eyes that the robot now has to do with the camera. But in this picture, you might have already recognized that, okay, that's a spray bottle, that's a laundry detergent bottle, there's maybe a can of soup on the right side, and there's something that looks like a transparent bottle in the front. But how do you tell a robot to distinguish between all these different objects? We have 15 years, or whatever your age is, that many years of experience learning about these different types of objects that we can recognize all of them, but a robot doesn't know any of that. And embedding that information inside a robot is actually pretty hard. All right, so say we solve the problem of visual perception. So the robot can see everything and understand meaning in objects. Well, the next problem is, how do you manipulate these objects? If you think of robots as being essential to our human environment, so if you want a robot today in your home, well, that robot has to have the ability to interact with the environment, right? So say you ask the robot to go and open the door. Well, first of all, the robot needs to know how to open a door. It needs to understand what a door is and where to grab it, right? These are information that seems pretty trivial to us because we already know that. But what does it mean to a robot? If you ask a robot to pour a cup of tea for you, well, it has to first recognize where the kettle is. It has to understand what a cup is, and then grab both of those things and then do a pouring motion. You can tell the robot that this is what a pouring motion is, but then the robot only knows how to pour one type of mug and one type of tea, and it can't do anything else. So manipulating with the environment is a big part. I already mentioned social interaction being an avenue of application for robots. But if you ever talk to an automated system on a phone, for instance, if you have called customer service for any reason, you know that you can basically distinguish an automated system from a human immediately. And that's a big challenge in robotics, and that we're trying to sort of overcome and making that interaction more smooth so that it feels more human-like. And the last part is creativity. You probably hear your elders tell you that if you're doing something creative in your life, then you're probably not going to be replaced by a robot in the future. That's partly true. We don't know what a sense of imagination means for a robot. And what is creativity? It's just putting together different ideas to create a new idea, right? So again, that sense of experience, that sense of imagination is basically absent in robots today. And that's why we don't really associate creativity in robotics yet. So what does this mean physically? Well, these are just different parts of a robot that don't that are not up to the level of progress we want. What does this mean physically? So I'll get a little bit technical here, but we'll jump right back into applications right after. So when we think of robots in an environment, we think of either they're going to be controlled by humans. Every single motion of the robot is going to be a human controlling the motion. So the robot is not going to have kind of any mind of its own, right? Where it's going to go, what it's going to do, a human is going to be sitting behind a joystick and moving it around. And that's very good when you have an unstructured environment. So say, again, you have an earthquake, you have lots of debris. Well, a robot is not going to be able to understand how to move around in all this clutter, right? It's not going to know that I need to go over on the smooth side and then find this kind of gap between two rocks that I can go in. So that's why you have a human controlling every motion. The other application is in surgical robotics. Again, your human body is very messy inside, right? There's lots of different organs that all kind of look the same. They all look red, they all look blood colored. So that's why you have a human sitting behind these surgical robots. None of these surgical robots you ever see in these videos are ever automated. They're always controlled by a surgeon sitting behind a joystick and controlling every motion of that robot. And you want that because, well, you don't want to have a safety risk associated with the robot kind of doing what it wants because you trust the surgeon and you want that surgeon to be controlling the robot. Well, you can kind of take the human away when your environment is very structured. So I mentioned factory automation, where, again, in automobile engineering, for instance, putting together different kinds of parts for a car, that's a very structured environment. The same kind of car is going to come on your line, in your assembly line, and the same kind of part is going to go in. And you just have to do that 50 times a minute, for instance, right? So the robot is fast and can do that same kind of motion over and over again. I apologize if there's background sound. Someone is cutting their lawn next to our house. And the second application I mentioned was in a warehouse, or an Amazon or Flipkart warehouse. You have these robots which kind of go in on the floor. They pick up the shelf and they bring it to a human picker. Well, what happens when you take away the human and you have an unstructured environment? Well, that's what the challenge in robotics today is. We're trying to figure out how to do autonomous operation in an unstructured environment. So you have no human. So in the first case, it's a self-driving car. And you might think, well, roads are very structured, right? You have lanes, you have you have signs, you have stoplights, you have traffic lights. So it's a very structured environment. But as soon as you put other humans in the picture, so you have pedestrians, you have other human drivers, those are unpredictable people. You don't know what the pedestrian is going to do. You don't know what the other human driver is going to do. So that's why it's a very unstructured environment. And that's why self-driving cars are still not, you don't see self-driving cars right now out on your roads. They're still a lot of time away. The other application is generally in autonomy and unstructured environment is that you want to pick up objects in a clutter. So if I just put a bunch of things, you clean out your room, you put everything in one big bucket. Now you want to take all the stuff from the bucket and put it in your shelf. You want to organize all those objects. Again, that's a very unstructured environment because all those objects could be on top of each other. You can't see what's on the bottom. It's a very hard task. And in fact, one of the challenges that Amazon today has is they have these robots bring the shelf to a particular place where the humans can pick the object out. But the slowest part in their chain is actually the human picking the object out of the box and putting it in the box that gets shipped to you, the person who bought it, right? And that's, if you think that seems like a very simple problem, but in this warehouse, you can see millions of different types of objects. To tell the robot how to pick up every single type of that object is very hard to do. So a couple of years back, all these brightest minds in robotics, and there were 16 top faculty and our professors in robotics came together and they said, what are the big challenges? What are the grand challenges in robotics that we want to solve, in the coming 5-10 years? And I'm not going to go through all of these, but because I kind of covered all of them, but the main ones I'll try to pinpoint. Number one, the new materials and fabrication scheme. So if you think of robots of tomorrow, they need to be able to do lots of different functions. You can't have one robot doing that one job and then another robot doing another job. You'd have to buy 50 different robots just to do things around your house for that, right? So you want robots to be able to do multiple different things. You want robots to be soft. You want them to be compliant because, well, if they bang into you, you don't want to get hurt, right? Humans in general are soft. They're very squishy. And you want kind of robots to be that way too. So if you're interested in chemistry, material science, this is kind of a big area of robots that you can be looking at in the future. Number 3, power and energy is a big one too. If you want robots to be really small in the future, well, we have to figure out what batteries will look like. Again, this is a big part of chemistry because if you have a really tiny robot, you have a really tiny battery, and that robot is only going to be on for maybe 2 or 3 hours, and then you can lose that robot. So that's a big part of a big challenge that we need to solve in the coming years. Number 4 is robot swarms. What swarms basically means is giant clusters of different small objects. If you see a group of birds in the sky, that's a swarm. And we want this because you can now build really simple robots, very tiny, simple, very cheap robots. But you can have hundreds of those robots, and now those 100 robots can do one big task. So this is how humans actually do it, right? If you ever go to a construction site, you don't see just one human working there. You see lots of different humans collaborating with each other, maybe picking up two sides of a heavy object. We want robots to kind of do the same as well. Number 6 is AI for robotics. AI means artificial intelligence. Artificial intelligence, basically, you're trying to learn how to learn. So robots today don't know how to learn a task. So if you give it a task that it doesn't know how to do, it's not going to be able to do it. And we're trying to figure out how robots can recognize patterns. So you can have pattern recognition, you can have reasoning that humans are very capable of, but robots aren't. And lastly, number 10 is robot ethics and security. This is, again, always in the news because people think that robots are going to be kind of these killer robots that are going to be taking over the human race. But to some extent, we want to have responsible innovation in robotics because this field is fueled by data. So we need a lot of data from how humans behave in order to inform what robots should be able to do. And we need to collect that data responsibly. We need to have careful consideration of the legal and ethical barriers that robots shouldn't cross, or how we should design these robots. So this kind of gives you an idea of what challenges and what areas of robotics people are still working in. Well, all right. So now you're saying, I'm interested in this field. What do I need to do going forward? What areas do I need to study in? Well, I'll tell you, whatever area you decide to study in, you're going to interact with the robot in the future. We think of robotics generally as a mechanical engineering, electrical engineering field. We need to learn physics, but that's only part of it. That's only designing the physical makeup of the robot. So that kind of what the robot looks like, what the robot can do. More and more, we're seeing computer scientists, mathematicians take part in designing robots because they are the people who are deciding how to control a robot. You have really complex systems with lots of different parts and lots of different moving pieces, and you need to coordinate all of them, and that's the job of a computer scientist, a software engineer, a mathematician. We're starting to see a lot of areas in robotics being applied to medicine. So biologists, biomedical engineering are starting to also see a lot of involvement in this field. I talked about medical robotics, and I'll go into a little more detail about that. So surgery and rehabilitation of prosthetics. These are all jobs for biologists, for doctors looking to use robots for the applications. The other interesting application of biological systems in robotics is if you've seen robots that look like animals. So biologists are very interested in creating robots that behave exactly like an animal, because then you can get up close to different kinds of animals and then study a living organism. So emulating a living organism is another application of robotics. All right, so we know robots in the future will need to interact with humans. For that reason, they need to be social systems too. They need to be able to know how to behave similar to a human-like system. For that, you need psychologists, sociologists, neuroscientists to tell us exactly how these systems should behave. I mentioned robot ethics and security being a big challenge, a grand challenge for robotics in the coming years. That's a job for philosophers, for people who are studying law and public policy, to decide what kind of regulations, what kind of barriers should be put so that people are designing and using robots responsibly. But also, we know that robots are going to be taking over a lot of the jobs that humans are doing today. So how do you take care of all the displaced workforce that is going to come as a result of automation? And that's, again, a job for, if you're in the government, that's kind of your main, it's a big worry for you, because you're trying to decide what kind of public policy should I put in place to take care of all these people. If you're a business owner, if you're an economist, you're thinking whether I should put in a robot in my factory or not. What is the cost versus benefit of putting in a robot? And that's again, very common in pretty much every major manufacturing company today. They're all trying to see how much productivity can I get out of this robot, and what is it going to cost me to buy it and maintain that robot. So supply chain, business economics, these are all very entangled with the field of automation of the field of robotics. And lastly, I worked with a lot of industrial designers when I was working at a surgical robotics company, because you wanted the surgeons and the nurses to be able to use the robot very intuitively. There shouldn't be a simple system that becomes complex just because it is not designed properly. So you're trying to debate whether the form or the function of this robot should take priority, what the ergonomics of this robot should be. And in general, you don't want the robot to look creepy, right? So you want it to be approachable and easily usable. And that's a job for industrial designers, for artists, for people in marketing and product development. So again, I'm maybe covering about 50% of the different academic disciplines which actually go into making a successful robot in any company. But there's lots and lots of other people who actually put in their work to make a product, to make a robot product. So I'll give you an example of what this looked like when I was working at Intuitive Surgical. What Intuitive Surgical makes these are these surgical robots. So the picture on the left you see is this actual surgical robot. So these are the robots that kind of go and interact or interface with the human body or the patient. The surgeon is sitting at the second image, which is a console. It's where the surgeon sees what the robot sees. So they're usually in the same room, but they're operating using these joysticks so that they can get really fine control of the robot inside the human body. So if you have, and there are like 6,000 of these systems. So this is not a specialty equipment. It's very common in major hospitals across the world. Actually, I've seen these robots in hospitals in India, and they're very common here in the US too. So if you ever talk to a urologist or basically any kind of surgeon and you mention Da Vinci robot, they will almost always know what you're talking about because they've either used it or they've seen it in their hospitals. So what does this do? What does this robot kind of do? So I tried to find images which were not surgery videos because I know that can be gross and people don't want to see it always. So I tried to find diagrams and figures that are just schematics, not actual human body images. But if any of this disturbs you, I apologize in advance. So in the top left, you kind of see what surgery used to be done in the past. The conventional way of doing surgery was make a giant cut in your body, and then the surgeon would put their hands in and interact with the organs. The modern way of doing a lot of the surgery is the B image, is to just make tiny incisions. So these are kind of the size of your pinky finger, actually. So 8 millimeters to 10 millimeters in diameter. And you make these tiny incisions, then you put the instrument through that. So the bottom images, you see that instrument going through that tiny incision. So an incision is basically a cut in the body. And the reason to do this is lesser infections, faster healing, in general, a less complicated procedure. This area of surgery is generally called minimally invasive surgery. It basically means less invasion or less, smaller cuts in the body. And surgeons usually do this using laparoscopy tools. So again, these are just technical terms for basically what I'm describing here. But what surgeons will do is about 4 or 5 practitioners will stand around the human body because you need that many to hold all these instruments. And then they will look up at a screen and then try to operate at the bottom. So imagine you being the surgeon in this case, right? You're looking up at a screen. So on the top and the bottom right image, you see kind of what the camera sees in one of these ports. And then you're trying to do something in the bottom. So again, that's already a very difficult task as a surgeon because earlier you were just looking straight down at the patient's body. But not only that, look at the bottom left image. And if you see me, I'm kind of showing what that looks like. So say this is your skin and you're putting in the instrument through one of the small incisions. And you're holding the instrument down here. The patient body is down here. If I push the instrument to the left, the instrument actually goes to the right because that there's a fulcrum point on the skin. And I'm describing all of this just to tell you how difficult the surgery actually is. So again, hats off to surgeons, but it takes immense practice and lots of years of experience to master this kind of mirrored motion or reversed motion that you're trying to do. So it's a very difficult task. Well, this is why Intuitive Surgical or Da Vinci Robot said, well, we can make this a lot easier. First of all, we'll give the surgeon direct view of what the camera is seeing inside the body. So we're going to put this kind of VR, like a virtual reality headset, kind of just where the surgeon is looking. And then we're going to give them joysticks so that they can do exactly what the instrument will do inside the body. And then they'll be in the same room, so they will be doing kind of the same motion that the instrument is actually doing inside the body. And now you can control really fine motions of the instrument inside the body, and you can make really precise stitches. You can make really precise cuts in the body. So this is kind of what the system looks like. You have a surgeon sitting at a console and a robot doing exactly what the surgeon is doing with their hands. A lot of you have probably seen this video. It went viral a couple of years ago. So this is actually already this is pretty old, but this is doing a surgery on a robot, on a tiny grape. And you'll see in a minute why this is even more interesting than it actually looks, because this entire process of using these tools, again, a surgeon is doing all of this, is done inside a bottle. So through this tiny port, you're basically cutting a grape and then suturing it back or stitching it back together. So it's very impressive motion that you can now do because you are using a robot. So there are different configurations of this robot. I mentioned you can make multiple ports, or you can make a single slightly larger port and then put all your instruments through that one port. And again, this is all controlled by the surgeon sitting at a console and then moving these action instruments. So this is another configuration of that same Da Vinci robot that I was working on at Intuitive Surgical. So you can have 4 instruments here. Maybe one is a forceps, one is a scissor, and one has to be a camera because you want to see what's going on. So again, these are super cool, very interesting robots that actually make a big impact in surgical outcomes for patients. So if you're curious as to what, or if you don't care, that's okay too, but what I'm doing right now. So I mentioned I'm doing my PhD at Yale University, and I'm doing it in this lab called the Grab Lab, and the challenge that we're trying to solve is robot manipulation. So I mentioned that manipulation is a big challenge for robots today. We don't know how to manipulate different kinds of objects. So what we do is we design robot hands for different applications. So these are just some designs of robot hands that I've built in the past or worked with in the past. And that's kind of what my PhD is going to look like. It also involves doing a lot of math. So you're trying to understand what these robot hands can actually do and what kind of hands should we make. The other interesting part about this is that we have about 70 different types of objects in the lab, everyday objects. So these can be cans, boxes, fruits, and we use these objects. We put our hands, we use our robot hands to manipulate these objects because we want to know how good they are, how they're performing. So we have sort of just a giant box of all these different kinds of very fun objects. We have toys. There's lots of different types of objects in the box that we get to play around with the robot hands. The best type of robot hands are actually human hands. So our human hands, again, can do so really fine motions. You've probably seen people do like really cool pen tricks or art with their hands, right? So our human hands are probably the best kind of hands. And to achieve that level of manipulability or dexterity with robot hands, we try to study what human hands actually do and how they perform. And then we take that also to apply into the field of prosthetics. So we also have some people in our lab working on making hands for people who, again, might have lost their limb or have lost function in their limb. So we kind of take application of robot hands and then put it into designing human hands. So I know I covered a lot. I hope that gives you some insight into what robots can and most importantly cannot do today. What people in this field are trying to do, and the many different types of academic disciplines that come together to make a robot product. I hope that gives you some appreciation for what robots can do in the future, and I hope that it gives you an idea of what you will probably see in the coming years. I think there's probably some questions that you might have in the chat, so if there's nothing else, I can go through those questions in the chat. So a couple of questions are about robots walking. So again, walking is actually a big challenge in robots. Anytime you want to think whether a robot can do this or not, just imagine what you're doing for that task. So a human walking takes a lot of information from your feet, right? You have a sense of balance by the fluid in your ears, so you know that you're upright. You have information from force that is coming back to you from your feet, so you're kind of getting that information as well. So a lot of data is going into your brain, and then the brain is start processing that for you to take the next step. And generally, walking is a big task for robots. We can do it. We can walk over rubble. We can walk over any kinds of steps, hurdles, any kind of obstacles. That's, again, very hard for the robot to do. So walking robots are still a little far out. So yes, robots in therapy are generally restricted to specific areas of therapy. So you have specific questions that you ask a robot, and you kind of get those answers back, or they're doing very simple things and tricking you into thinking that they're actually doing a lot more. For instance, they're just asking you leading questions. So for instance, one of the robots that people found really fascinating was a robot that would just ask you why. So say you went to therapy, you talk to this robot, and it would just ask you, well, why do you think that? Well, why do you want to do that? And that seems like it's a great therapist, but it's just doing a very simple thing of asking you back why. So it can do very simple things. So yes, one of the questions about the emotional needs of the patient. Absolutely, yes. I think doctors are generally trained to how to talk to patients, and they're not going to be doing that. Robots are not going to be doing that anytime soon. Well, we're even far away from the robot doing the surgery itself. We're still having a surgeon using a robot as a kind of like a tool. They're just using the robot as a tool to do the surgery, right? So the robots are not going to be taking over the medical field anytime soon. There's a lot of, again, hype about Tesla cars because they're these really cool automated driving, self-driving cars. You've probably seen just enough videos on YouTube also of Tesla cars crashing. That's generally because one of the things that cars struggle with is road conditions. So as human drivers, we are capable of driving in sun, we're capable of driving in shade, we're capable of driving in rain, lots of wind. Even if there are no road lanes, we're still able to drive, right? But Tesla cars are usually, they encourage you to use them only in very dry conditions, very bright conditions, where they're going to be, they know that they can see the world around them very clearly. And also they only generally are allowed to use them on highways. So where there's, again, everyone's staying in their lanes, everyone's driving mostly normally, but I don't think you're gonna see a Tesla car on an Indian highway anytime soon, just because of how people drive or how unpredictably people drive. With the surgical robots, again, there's a question about how much time it takes. People have shown that it takes sometimes a longer bit of time because you need to set up this giant robot before the surgery can start. But the big advantage is recovery time of the patient. So if you say the patient came in on a Monday for an open surgery, it might take them 2 months in the hospital. I'm making up numbers here, but they might take them 2 months in the hospital. Well, if you use this robot, they might be out in the end of the week or maybe in the next couple of days. So overall time of the patient in the hospital reduces by a lot. And that's kind of the big sell of this surgical robot. So yeah, so there's a question about how do you program robots and how do you kind of teach robots to do something. That's kind of what falls under computer science, software engineering. It can be lots of different types of programs that you use to tell a robot what to do. People are trying to develop programs that even a novice or basically anyone without any experience can teach a robot what to do. So we're kind of coming up with ways of guiding the robot. So if I have a robot arm, I can pick up the robot arm and then move it around and tell it exactly what to do. And then it'll repeat that motion. So people are actually trying to make that process easier to teach robots how to do things. And you might, even in a field outside of computer science, be actually teaching a robot how to do something. There's generally a lot of skepticism about will robots be smarter than humans and basically take away human jobs. It is true, yes, robots will take away a big chunk of human jobs you already have. If you think about an automotive factory, so a car making factory, there's a lot of jobs that were there maybe 10 years back that aren't there today. But in general, people think of robots taking over. In the near future, robots will be kind of replacing jobs that are repetitive. So if you're doing the same kind of job over and over again, jobs that are dull or dangerous, those are the kind of applications where robots can more easily take over jobs. For things like acting, there's an example of acting and teaching here. No, you're not going to see any robot teachers at DPS anytime soon. So yeah, so there's a very good question about robot talking and answering like Siri or Google Assistant. These are actually great examples of kind of social systems. You feel like you're having a conversation with them, but you can still tell that it is a robot that is kind of answering your questions, right? It has come a long way, and that's partly due to artificial intelligence kind of learning how to talk to someone. If I'm going over time, please let me know and I can stop. But there's lots of good questions here that I'll just kind of keep reading on and answering. There are some questions about robots helping social issues, issues of today like climate change. There definitely are. One of the areas of robots that people see helping climate change is monitoring. So there's a lot of surveillance robots that go into forests, can help you track wildlife, can help you track progress of a forest, of a natural region. So it can tell you, you can basically go into areas where humans won't be able to go and say, look at an ice sheet that might be melting. So yes, there's lots of applications of robots and helping fight climate change and global warming as well. Again, I talked about employment and robots kind of taking over human jobs. Most people agree that a vast majority of jobs are safe from automation from robots. But yes, people are going to sort of, it's not that robots are going to take away or eliminate jobs. They're going to kind of shift our jobs into a different area. So you might have more people. My robotics professor actually used to give this example of a calculator or a computer, right? Back when he was a student, they would do all the calculations with hands, basically with a pen and paper. But that didn't mean that when computers came along that his job was replaced. Basically, he was able to do more calculations with a computer. So it kind of shifted his job a little bit more. But that also required him to learn how to use a computer. Now, if you magnify the scale at a level of a country, you need to train your workforce. And that's a matter of public policy, of government policy. You need to train your workforce to be able to handle that new level of automation, a new level of robots that might come in. So yeah, there's definitely concerns about robots malfunctioning at times or when they're performing an important task. What happens in that case? So this is an area of, particularly because I worked in a surgical robotics company, the regulations around medical devices are extremely strict because you don't want the robot to malfunction at any point. And generally when you design these systems, you design them with something called factor of safety. This is applicable to bridges, robots everywhere, where you design something to be 10x better than you expect it to work in. Yeah. Sorry, yeah. All right, and I can stop screen sharing while I answer these questions. So there were a couple of questions about robots being used in armies and robots being used in militaries. There's a big ethical question surrounding it. People discuss it at a great length. Should we have robots in military applications? Should we not? Some people think the argument for it is, well, you're taking a human out of a dangerous situation, right? So it's again a matter of what do you prioritize, robot's health or human health? So you want to kind of take away that that dangerous job, then you kind of want that application of robot. And the other side of the argument is, well, now that you have a robot that can do a job that a human can do, but maybe 5 times, 10 times better, you're going to be more lenient in deploying that robot. So there's an argument for and against it. It's certainly a matter of, it's an ethical question that people are still debating about. So it's not a clear-cut answer on what, whether we should have applications of it in military or not. In general, we don't have robots which are even close to being as smart as a human. You often see news about a robot beat a human at a chess competition, or another kind of this board game that you might have seen around. Again, these are very specific applications to that particular game, for instance, right? If a robot beat a human in chess, that robot can only do one task. It can be very good at chess. If you go and ask it to get you a glass of water, it's not going to be able to do that. So in general, overall competence of humans is far, far beyond what any robot can do today. And we're kind of developing robots for very specific applications. And that's kind of where we're focusing our energy and time and money on. So there's a couple of questions about home robots. I mentioned a robot vacuum being pretty commonplace. People used to think that nobody wants a robot at home. But when the Roombas or the robot vacuums first came out, people started treating them as pets. So people would dress them up, they would put kind of garments around them, and if it ever broke down, and the company would say, all right, can you send us the robot back? So we'll send you a new one. They would say, no, we want this particular one. Can you just fix this exact robot? So people treat the robots kind of like pets. And that might be a good thing, but that actually might be a bad thing too. Say you put a robot in a classroom, if the students get very attached to the robot, now you have taken away the robot after maybe a year, and the students have lost kind of a companion in the classroom. So social connection with a robot is actually, can be harmful too if you don't do it the right way. If you don't put in the work that goes into kind of implementing a robot and then taking it away. In terms of years, I think people generally joke that with self-driving cars, is a very common joke that a self-driving car is always 10 years away. No matter where you are, it's always 10 years away. So 10 years back, it was 10 years away, and 10 years from now, it's going to be 10 years away. And that's just how it is. People always find new problems, new issues that stop it from implementing it further. So I don't think companies will tell you that our product will be ready maybe 5 years from now, but it's for sure that they're going to come across some difficulties, some issues. And nobody can really tell you when a particular robot will be implemented in the field and that robot will be successful. So someone mentioned Sophia as a robot. So yeah, Sophia was a humanoid robot. I think the big application or the big goal with that robot was, can you mimic human emotion? Can you put a robot in that looks and behaves and expresses like a human? And a big part of that was just kind of showing that there was some software that went into sort of conversation. But again, it was pretty simplistic in its implementation. Yes, I know Elon Musk loves to tweet about self-driving cars coming soon, but I think he's again one who always overpromises. So, which is good. I mean, you always want to have high expectations in your products, but realistically, it's going to take quite some time and quite some time into these problems. There's a couple of questions that I glossed over, which were more about academics. I'm happy to answer them. Again, I didn't share my email, but if you find me on Facebook or shoot me an email, I'm happy to answer any kind of questions about academics too. Why PhD, why computer science, why anything particular, and I'll try to answer to the best of my abilities. I'm certainly not an expert, but I'll try to. There's a couple of questions about what machine learning, what artificial intelligence means. In very basic sense, it's pattern recognition. So you give it a bunch of information and you kind of predict what it'll do. So it's, in the most simplistic sense, it's kind of extrapolating based on what you already know. So if I give you 5 different types of coffee mugs, if I give you a 6th coffee mug that you haven't seen before, you should still be able to tell that that's a coffee mug. And that's kind of, again, I'm simplifying it to a great extent, but that's kind of a very simple definition of what machine learning is trying to do in a very simple sense. It's hard to say what kind of percentage of work robots can do compared to humans, because again, robots can do very particular tasks, but they can do them very well, and as compared to humans, which we can do a wide range of things, and a lot of things we're actually better at. So with robots particularly, in how they look like humans, there's something called an uncanny valley. Uncanny basically means weird, creepy. And so people, when they were making robots initially, they wanted to make them look like humans as much as possible. But some people realized that if you make a human-like robot, a robot that looks exactly like a human, it's actually a little creepy and people are weirded out by it. So we actually want robots to look like robots, or what we expect robots to look like, or we want them to be basically like exactly like a human, but we don't want them kind of in between creepy way. And that was generally referred to as an uncanny valley because it kind of drops your perception of what a robot can do, kind of drops. And again, please feel free to stop if you don't have time, but I'll continue answering questions until then. So there was a question recently and before too about robot pilots. Well, we already have a very good autopilot system. Robots, that's an autopilot system is kind of like a robot, but people say that you can basically fly a plane and land it in stable conditions, essentially without a pilot. But ask yourself if you would ever get on a plane that doesn't have a pilot, even if you know that 90% of the time the autopilot is running the plane that you have flown on, but nobody will get on a plane that doesn't have a pilot. So a lot of these jobs are kind of there for human satisfaction. Not saying that pilots will go away anytime soon, because you can never predict weather conditions and things like that. So pilots are always going to be there, or at least in the near future. But there's a lot of jobs which we kind of don't want humans to just leave because we don't trust robots that much. There's a question about if robots make people happy. One of the studies that recently happened at Yale was in times like this, when all of your friends are basically at their own homes in times of quarantine, they saw that people were not socially interacting as much and hence weren't as happy. So they actually had robots, tiny little robots at different houses, and people could interact with each other by controlling the robot at different houses of their friends. So in a way, that's kind of making people happy and bringing back the social connection that we've lost because we're not meeting with each other. Yeah, I will stop there because I know I've gone way beyond time already. But again, I can briefly share my screen if you just to show my email, and then we can. I'll stop right after. Oh, sorry. Yeah. Right. I think that's probably it. Thank you again for having me here to speak, and I hope I was able to give you a good idea of what this field is about, and it was useful to you and wasn't just someone lecturing at you for 45 minutes.
Thank you, Mr. Vatsal Patel, for this wonderful session. It will be a source of inspiration for all of us. Now, I'd like to introduce the person behind all IT help, the person behind all technology, our Vice President, Mr. Yasir Nana, to share a few encouraging words. Over to you, sir.
Well, Thanks, Vatsal, for that wonderful introduction to the world of robotics. I did mechatronics when I was in my college, and I found that that field was, just evolving. So I'm glad to see that it has evolved so much. And automation and robotics is indeed something that will lead the way in the future. And also I think students need to realize that they need to, it's not just engineering students who would be finding jobs in robotics, but every field of study has a role in automation and robotics, and that's the amazing beauty about this field. So thanks, Vatsal, for enlightening us on this on the new developments. A lot of our children are already aware of the developments, but to hear it from you, as they say, from the horse's mouth, you're there in the front line doing these things, and at one of the top most prestigious universities in the USA, Yale University. It's an amazing feat that in itself, that you have achieved so much, and you have been admitted to the highest degree that you can achieve, that is PhD, in such a prestigious institution. So I'm sure there's a lot of things in this field that you know about, and you have summarized it and as best way as possible. So thanks a lot, and do keep sharing any updates that you have, any big breakthroughs that you make, and I'm sure we'll have more things to be proud about you and your achievements as we go along your journey. So thank you, and virtually welcome to Qatar.
Thank you, sir, for your motivation.
Thank you.
Thank you, sir, for your motivating words. Next, I would like to request our Vice Principal, Senior School, Ms. Mary Cruz, to share a few words. Over to you, ma'am.
Good evening, everybody. Yes, ma'am.
Yes.
Good evening, everybody. It was wonderful listening to Mr. Vatsal Patel in detail, everything about robotics. And I really found it very interesting because robots are something which was used like a toy earlier, is now coming into play in our daily life. In whatever walks of life, if you see, robots are being introduced, but they cannot replace human beings at any cost. That's the underlying statement, because they need human beings to control them. So Vatsal Patel has nicely explained about the application of robotics in agriculture, in medicine, in the field of vehicles, motorbikes, automobiles, and things like that. It was really wonderful. And nice listening to you, Vatsal, because you broke it down to simple words so that children could understand. Waiting for such more speeches from you, and God bless you. Stay connected. Thank you.
Thank you, ma'am. Now, I'll be proposing the vote of thanks for this evening. We would like to thank our guest, Mr. Vatsal Patel, for taking out his precious time, adjusting his time zones, for sharing his views, and giving insight into the field of robotics. We would like to express our sincere gratitude to the school management and our principal. We are fortunate to have the wonderful support of our vice principals, Ms. Soma Bhattacharjee and Ms. Mary Cruz, and Ms. Vijayashree, activity coordinator, Ms. Preeti Modi, along with the team of teachers. We would like to extend our thanks to Mr. Harish and the IT department, Mr. Abhishek Jha and the computer science department for their cooperation and support. A very special thanks to Ms. Jaya Majumdar for the smooth organization of this event, for taking out their time to learn more. We thank you all for being with us on this memorable evening.
Thank you, and good evening, Vatsal. Thank you so much. God bless you, and may you achieve greater heights in life.
Thank you all. Thank you so much. It was a lot of fun. Yeah.
Yes. So we'll leave the meeting. Thank you.